That's weird. Oh, there's no sound on that microphone. Let's have a look. Hello everyone, I'll try this again. I moved my computer the other day and plugged all the things back into different ports, so obviously the USB port was tied to the particular microphone. Yeah. Anyway, okay, I'm on the sound mic right now anyway. I need to get the game mic going. Let me just sort this out. This is great preparation. It'll take a minute. Well, it won't take a minute. Okay, game mic. Here we go. Back onto that one. Right. Yeah, because I plugged everything into different ports on the computer because I pulled the computer back out. And obviously the microphone's tied to that particular port and I happen to plug it into a different one. Anyway. So, I'll try this again. So, hello everyone. That's Dave, Johnny, Sheridan, David, and Kim. Hello. Good to see you, Kim. So, I've got a new toy to play with today, so I'm not quite sure if I can get this right. I probably can. How am I do this? Actually, I might need to make some setting changes. So you know that I was trying to get this free touch stick thing to work, right? And I was having lots of issues with, well, my version of a free touch stick, my build of it. You know, free touch stick software. I was having issues with my Bluetooth on my computer being too old. And I upgraded the Bluetooth and it still didn't work. It's to do with the chipsets. So what I've done now is I've gone back to my original Wi-Fi card and everything on the computer, which is why I put it all out. That is because the range was really, really short, even on the Wi-Fi. Like I used to be able to connect to the motorhome, which is its own Wi-Fi and internet connection out there on the driveway, and I could connect to that Wi-Fi network with a strong signal, like 3 bars out of 3, sort of thing. And with the new Wi-Fi card, I couldn't even see it, so I ended up ripping that back out again and putting my original stuff back in again because it worked better. So for now, this is on the shelf, but my wife's been good to me and she's bought one of these. So I've now got a Stream Deck. So I can very quickly and easily change scenes by pushing buttons on this thing here. I've got to get used to using it because obviously it's new and I need to get used to the layout. 1080p is available, that's right, it is. I figured out what was going on there. Now, when I originally set up my live stream configuration on YouTube, I specified what the size was. And YouTube is actually able to automatically scale depending on what the stream is. And at the time I'd set it as 720p and I didn't realise that I'd done that. And because obviously I was just trying to figure out how to get the thing working. And when I tried it previously, I tried to do 1080p on my streaming software before. I couldn't get it come out as 1080p in the stream. It's still only 720, and that's because the YouTube setting was incorrect. So now I've got both set correctly, hopefully, and hopefully my internet connection behaves well enough to be able to keep on streaming at this rate. And oh, then I said I've just seen I've dropped some frames, so might have jinxed it already. So, yes, we shall see how this goes. So I'm streaming at 1080p for the first time ever. But I don't know if my internet connection is going to hold up. So I've already dropped down my frame rate, or my bit rate, to 3000. I might have to go slightly lower. I'm not sure how this is actually going to handle it as far as quality goes, depending on what I'm doing, how much movement was in the frame, that kind of thing. So if I go down at 2000 right now, we'll do a big test, right? 2000. Which is usually like the lowest I have to go generally. Sometimes I have to go to 1500. But, so I've gone at 2000 now. How does this look? Let me know if it gets juddery or anything or quality disappears. Big movements. So it needs to refresh lots of pixels. Yeah, so Stream Deck, yes indeed. Pretty cool. I actually think I need to change the settings because right now I'm switching between... Hey Peter. I'm switching between OBS and I'm actually using Chrome to do the stream viewing and chat and stuff, right? So each time I click on Chrome, my OBS setup changes because I've got it setting so it switches between apps. So different apps have got different key functions, which is really convenient. But if I want to control OBS all the time and I'm looking at Chrome, not so good. So I think I need to do some setting changes here. So when it's in Chrome, it has the same setup as it has in OBS. That way, it'll just ignore that. Because I tend to use Safari as my main browser anyway. So let's go and change my settings here. Should I show you what I'm doing? Don't see why not. Let's drop this up here. OBS. Exactly why I want to change this, because I've now dropped out. And let's go in here. Disk and yeah, that one, face screen, that one there we want. So there is the setup there. I'm using it in OBS right now. So what I need to do is basically mimic all of this over into my Chrome setup. I think I need to add a new profile actually. Yeah. Do you guys want to see me do this or not? I don't know, probably not. Let's see. Let me just I'm not sure this is going to pop up when I open this up. Give me a second. And now it's being funny, but I've got it. Is it because I've got it sitting over the top of OBS? No. I've got a bug. Got a new bug. I just found a bug. Okay. I've got a bug. Since I had it on the top screen up here, that menu won't stay there unless I go over it. Look at that. You see it? It's pretty interesting. Hey Fred, how's it going? Andre? Tony? Well, you could watch me play my stream deck, I suppose, but you know, yeah, I don't know. Why is it being weird like that? Let's reboot it. No, it's still doing it. That's odd. I seem to have triggered a bug somehow. Very interesting. Okay, so I need to basically copy my OBS profile actually. Yes, actually if I need to go to manage profiles, give me a second. Sorry guys, I should have really thought about this beforehand, but I didn't. Delete one is created. Make a new OBS profile, which you guys can't see right now. Just easier to see it down here. I'll show up here. Here we go. Now you can see it hopefully. Application, Chrome. Yay, right. Rename it. So now when I'm in Chrome it shouldn't, well it'll still be switching but it'll be using the same format. This happens. Close it off. Close off the software, why is it stayed locked on? Yay, there we go. Now I've got the same button format between Chrome and OBS. Sweet as. Right, that's that one. So what we're going to play with, that's a good question now. What tinkering's happening tonight? Yes, well, that is a good question. So I do have some packages on the desk there. That's annoying. This is in the way. Got a new soldering iron. You can see my old one sitting there on the desk as well. But so I've got some packages. I'm thinking I might need to open those up. I'm just trying to remember what's in them. I think I know what's in them, actually. Yes, I do know what's in the large packages. Who stole my hair? You all fell out. I actually cut it off. I actually quite like it this length, but it doesn't look as messy. But unfortunately, it does show the whole boarding pattern. You know, getting a nice landing strip down the centre there. Getting old sucks. Don't feel like a 40-year-old person anyway. I feel like a 20-year-old still, but never mind. So, as I was saying, I've got these packages here. The contents of some of these packages are things I need to do for a project. Now, if I spin this around this way slightly, you can see just there is a PCBWay box. That's got some boards in it, which I've had made. Sponsorship, by the way, so didn't cost me anything. And I've also got some other stuff in that box ready for this project I'm going to be building. So, I don't think I have all the bits I need yet, though. What's in there won't be all the stuff I'm waiting for. So it'll be a fair chunk of it, but not all of it. That's the trouble with being 1080. Now you can see more detail. You know, maybe I should do that. There you go. You can see a bit less now. Oh, the chat's disappeared in 4-way. You can't see chat in 4-way. I think I need to add the chat to that, don't I? How big is it going to be if I do that, though? Okay. We shall copy the chat, go into 4-way view. Where should I put it? Yeah. I'm not sure I'm going to put this chat window. I have to have it really small, like down here or something. Hopefully you can still see it. Can I crop this? Hold on. Scale filtering. No? Scaling, where is it? Transform. Been a while since I've had to do this. So, crop top. Top piece of the window off, we don't need that. There you go. Yeah, 75 looks good. It's marginally better, isn't it? Let's sort of peek around it. Side. Yeah, it kind of works, doesn't it? I don't know. I haven't seen more comments in a little while. You'll stop talking, or has something gone wrong? I've had something go wrong before, haven't I? Okay, I think my chat's frozen. Wouldn't be the first time. You're planning. Okay, alright. There's working in. Excellent. And somehow I've now got two chat windows. I've got one here, another one in the window itself. It's complaining about my bit rate being too slow. Oh, and I'm dropping frames. 1080p might not be for me, I'm afraid. Hey Rob, how's it going? Okay. Anyway, it's not tinkering with these bloody software. Why does this thing being so weird about that? It should be popped out. I've got two chat windows. Hold on. What's this thing doing? Have to bear with me, this is all just getting a bit crazy. Right. Not big exciting watching me play around my browser right now, is it? Yeah, let's just try and get this bloody sorted out. Is that still working right? Looks like it is. Right. Okay, I think we're good. Oh dear. Anyway, so what I was saying before. Yeah, coffee's getting cold, should drink that quicker. So what's in those packages there probably won't be enough for me to finish this project I want to work on, which is going to be kind of a review item project thing at the same time because of being sponsored by PCBWay. So I need to cover that, at least mention them, you know. So I'll need to look at that, but I don't think I've got all the bits on it. I'm waiting for some more service mount parts to arrive. I'm waiting for some 2 different resistors. I think I'm waiting for 2 different service mount resistors. So once I get those, then I can do that project. So I don't think I'm ready to do it today. But I think some of the other stuff in those packages could be usable. Yeah, I'm not sure. So something that arrived in my bag this week was little VCO modules, like POL VCO combined thing. It's like a little circuit board. I've got it on a desk, I should probably show you actually. The Datron has a circuit board in it that's about that big, and that is basically a VCO module using a chip which I can't remember the number of, and this has a voltage goes into it which then tunes some reactor diodes which adjust a oscillator coil resonance, and then it's got a little POL chip in there and stuff as well which works for it. And so this is the Datron is trying to string a bloody sentence together now, I think. So the VCO on the Datron isn't locking very well to line frequency. That is very, very erratic, and the noise on the Datron is quite bad. I'm thinking it's to do with the line frequency locking, because what it does is that the VCO in there adjusts the clock frequency and the clock rate of all the ICs on the logic system. So they're all synchronized with the line frequency. So any noise on the line, like 50 Hz, 60 Hz noise, whatever frequency you may have in your country, it helps to negate that by just basically being at the same point on the waveform every time. That way, that waveform has no effect. But my Datron is very, very touchy. I was actually having a really hard time getting to work properly. So I actually found some boards from AliExpress which basically do exactly the same thing. Let's see if I can find it. I think I've got it on my desk somewhere. Let me find it. So there's a few different options for this. It's something I could be playing with today. I'm actually really thinking about doing this today. So this is the first option. I'll get it in the packet so you can see it better. We should put one lip behind the other one instead of both at the same place anyway. What's the chip? It's a MC1648P. So this is the little module. Right. If it focused on it, it'd be great. Usual thing. And over this side. Yeah. Focus. Come on, look at something other than the background. Here we go. Kind of. Anyway. Hang on, how's it going? So this is a little VCO. So you inject a voltage in this and it outputs a frequency. Now the frequency on this is a 49.152 megahertz, or thereabouts, being VCO controlled. You can tune it up and down, which is what's the original circuit board is like inside the Soldatron. Now another option of Soldatron is actually a fixed frequency oscillator. I've got a few options here. So I've also just got a standard resonator kind of thing. Little, well, a standalone oscillator. Just a standard oscillator, nothing special there. Same frequency. I also picked up a TCXO. And I've also picked up this version of an oscillator, which has got a TCXO built onto it. So this one's basically a tunable TCXO. And what I was planning on doing is playing with the Soldatron and actually substituting the original board with one of these other ones. I haven't looked properly at the compatibility yet, so it may or may not work. This board here is basically the same architecture, except that the original board has got some extra amplifying on it, so extra amplifier transistors to boost the signal up or something. Maybe to give it more current drive or more voltage drive. I'm not sure. I haven't looked at it that much, but yes, I'm thinking TCXO. That's what I'm actually thinking about. Because an option on these is just a crystal oscillator instead of having a POL and a VCO system. So it's a locked frequency. So that may be better than the one which is jumping everywhere. I don't know. If it's an option, I would have thought it would be better. Options would be better, wouldn't they? Wouldn't an option be an upgrade? But then why would you use a complicated, convoluted VCO system if a crystal was better? Not sure. Hey Ricardo, how's it going? So that's something we could potentially play with today. My mind's not completely on it though, so I'm not sure. And over there I've got a Datron of some kind. I think there's a 1062 sitting over there, which I don't remember what I was doing with it now. I mean, I haven't finished it. I'm just trying to think what I actually hadn't done to finish it. Confused. I don't remember what I was doing with it. Don't know. Anyway, so finish my coffee before it gets too cold. So the other thing I'm waiting for, which could be in that packet or one of those packets, is a crystal or a packet of crystals. I have to buy a bunch of them actually. They're for the Datron, for the multimeters. Now my 1082 behind me here, so the 1082 that's behind me here, maybe it's a calibration. It could be that, Dave. Yeah, it could be that. Memory loss. Yeah. My memory's not like it used to be. Not at all. So, anyway, the 1082 I got behind me here, that has got the wrong crystal in there, and I need to change that. I haven't did a video on that yet. Yeah, I've just done it for the Patreons and membership, something like that. So, general public haven't seen a Datron 1082 video yet. It's only released to supporters at the moment. I think it comes out next week. Well, this Friday coming, it'll be. So I think crystals are in there for that multimeter, which means I could swap that crystal out and put the correct frequency one in there. But it also lists some different capacitors being used in the circuit as well. So I'm not quite sure if I need to do swapping of capacitors, and I don't have them, the ones that actually listed. So I don't know. If I had any hair, I've got hair. Look, there was hair there. Look, see, there's definitely hair. See, just not as much as it used to be. I don't know. Yeah, so you've got loads. Yeah, lucky. But memory used to be a lot better than it is now. It's pretty bad right now. The I think part of it is not getting enough sleep. I don't get enough sleep, so I think that kids kind of wrecks memory quite a bit. Oh, you know. I can remember all sorts of things. Like I could remember tiny little details about every repair I've ever done. You know, from like 2 years ago, 3 years ago, I remember all the little details about it. And now it's like, what did I do yesterday? Oh. So I could get his mailbag and got these surprises in mailbags. Like, oh, what did I get that for? Because I don't remember. Yeah. I remember eventually, but usually at the time it's not obvious. You know, post-it notes here. Yeah. Cherry blossom. In what way? Rub it on. So you have to sit there rubbing it into your head or something. I'm just accepting the fact that I'm getting older. And things aren't quite as good as they used to be. My eyesight's starting to go as well now. That's annoying. The past year my eyesight's got a lot worse. From being able to read the markings on surface mount parts to not so well. Anyway. Yeah, we're getting old. Yeah, anyway. So yeah, I haven't really decided what I'm going to work on. So yeah, the Datron was calibration, wasn't it? That's right. You were right there, Dave. You're right, that's calibration. That's why I don't really have to fix anything else on it, because there's nothing else to fix. Calibration's a bit boring now. I don't want to do it in a live stream. I'd rather just record it and edit it up and try and shorten it, because otherwise it'd be an hour of me tinkering with a Datron doing a calibration. Unless you want to see that. If you want to see me doing that, that's fine. Although my calibrator's not turned on. Yeah. Yeah, I'll have to turn the calibrator on and let it warm up for a little while, but it's possible, we can still do it. We can still turn the calibrator on now and then let it warm up for an hour, then do it. Be close enough. Yeah. Getting old sucks. Also, not getting old sucks, so, you know. Either way, it sucks. Yeah. Right. So I really didn't have a good enough plan for the day. I was sort of, I think I'd live stream on Sunday. And I didn't actually put any thought into what I was going to do. Yes, I'm just thinking, what can I do? We could do this PCBWay project, but I don't think I've got all the parts I need. I'm pretty sure I don't have all the parts. I'm waiting for some service mount parts to arrive. Involves a bit of soldering and assembly and stuff. I'll tell you what it is though. I'll let you all into that. So that is on my new scope, the 2104X Plus. That has an MSO option, and it has an MSO port, and you can buy the logic analyzer. I think it's like 16 channels you can do, and you can use all that. It's fine, but they're fairly expensive. I think it was something like $500 or something, New Zealand, something like that. I could be wrong. Make it a two-parter. So because I didn't really want to spend that much money on what it is, I mean, it's not an active probe, it's just a connection system. It's basically a way of connecting your probes to the scope input. That's all it's for. It's like an interconnect system, and I think it's a bit overpriced. So because of, I mean, there's obviously work gone into it by Siglent, and the actual quality of the cables are really high quality and that sort of stuff, so I can understand why there's a price point on it, but I think it's a bit excessive. If it's half that cost, I would have bought it. Anyway, $500 US with licensing. Okay, with licensing, yeah. Thanks, Rob. I knew you'd form me in if you'd here. So because of that, I have been made aware of a thread on a ublog forum where someone, or a group of people, basically been designing a DIY version. and I decided to do that. So I've had PCBWay make me the boards that they had designed. These aren't my design, this is the design of the guys from the forum. I just had them made. And I found some cables which are suitable. So I found these old Tektronix cables. These things here. And these are Logic Analyzer Probe, original ones. And these are coaxial ribbons. So this is a ribbon cable which is coaxial, right? So that's a shielded cable. So I found this and I got what's it, I don't know, a metre or so of each one, something like that. You know, there it is, and there's 2 strands there. So I've got heaps of that cable. This is the main reason I bought this, because I want the wire from it. And also found some original HP grabbers in the original bag. Bunch of those. I've got some more of these coming as well with some little cables on them as well. I've got some, well, these ones, some capacitors to go on there. I'm waiting for resistors, like I said. And in here are the PCBs. There and here. So this is what I'm planning on building. Let's say I've done all the parts yet. But in those packages here, I think there's the rest of the cables I need, which is the little grabber cables to adapt from the main one. I believe that's what's in there. And like I said, I don't have the resistors I need to populate the circuit boards. I don't have all the parts. Certainly overpriced, yeah, it is. I mean, for what it is, it's just some circuit boards with a few service mount parts on them to do matching, and some coaxial cables. Well, I put that cable there for what did I pay for that? It's about $50 US. I think I paid for that, and you know, a few assorted parts. I mean, the grabbers, I think I paid $20 US for those. 20-30 US. Let me know. Yeah. Oh yeah. Okay, that'd be an idea, Rob. We'll see once I get built. I'm not really too worried about performance of it. I just, you know, I'm not too worried if it's got like rise time issues, that sort of stuff. I'm not too concerned by that. It's not the sort of thing I worry about usually is rise times, but ringing is obviously a potential problem. We'll see if that's a issue or not. But yeah. So I've got the cables. That is one of the hardest things to sort out, was getting decent cables to use on it. Because you'd either use twisted pair or coaxial, and if you buy them new, they're expensive. So that was cheaper. Anyway, so that's a project I'm going to be doing. I don't know. Do I play with the Soldatron? I'm tempted to, really tempted to. But I'll pull a circuit diagram for this thing and I'll show you what I'm talking about with the Soldatron. Flipping from subject to subject. Let me just find the thing. And I'll show it in the top window. And when I'm in the Finder, I can't change views on here either. I have to go back to OBS. Automatic switching is going to be annoying actually, I think, in some cases. Right. 7061. Now I've got to find the right schematic. I think it's schematic 2. Once I find it, I'll put it up there. Yes, it is schematic 2. That's a good guess. Right. Fortunately, these diagrams aren't great. Just get it big enough so you can see it. Should be able to see it on screen, alright. So this box here, that is the plug-in PCB in the Soldatron. And IC101 is the same chip as I showed you on this device here. Thought my head's been cut off. Oh, let's trim this. because I changed Windows. There we go. Right. Yeah, so that's that MC1468, was it? And this is the oscillator section, and this is the control voltage comes in, Cat diode, 152 megahertz clock frequency, which comes out over here. Alright, 5-volt input. So all this got extra on this board, on the Ciglent one versus what I've got here from China, is these extra transistors on the output here. So it's 5 volts to 0 volt switching through here. Alright, so it's obviously just an amplifying section. I'm not quite sure what this IC actually puts out. Maybe the voltage is not quite high enough to be reliable, so I'm not sure. So yes, that's the thing there. And that's the original board, which I notice is not being very reliable. It's, I don't know, maybe it's overreacting to line frequency, I'm not quite sure, but it's jumping all over the place. And I think that's maybe why it's noisy. So I want to substitute this board. And like I said, I've got a TCXO, which I can drop in. Very easily I can drop a TCXO in there. 5-volt supply, ignore the control voltage, and it's output the 49.152 megahertz. Done. You know, very easy. And that would be one way of testing it. Or even just leaving it in there. But I would have thought that this would be a better version. So then it is actually locked to line frequency and reducing the noise, like the have the number of power line cycles, right? In most multimeters, which you use to reduce the noise getting into your measurements. That's why it has this. So I'm reluctant to remove it, but then I wonder why having an oscillator, a fixed frequency oscillator, is an option for these things. I mean, is it because this isn't stable? I don't know. Does it really matter that much? Is it just close enough is good enough? Don't know. So we could play with that. I mean, this is a plug-in mold. I can just take it out, unplug it, and we can inject our own signals and stuff. Once I figure out where the pins are, which pins are which. It is noted on the layouts in here somewhere as well, which I have to find. So that's something we could play with. And what it actually does, can I show you down here? I can. So it comes through here, it's got through these two buffers, one comes across down to here, it says clock frequency just here. So it's like system clock. And then the other one comes across through this other buffer. It comes down to this clock here, which then does more system clock stuff. So, and it also gets divided down to, you know, these various frequencies and stuff too. So it's interesting. So this has got a supply frequency input here. There you go. The AC mains comes in through these optocouplers, through these to buffer them. Is it HC390X, is it? Can't quite see it. And that comes into this thing here, which is the phase detector. Alright, so it gets divided down to 50 Hertz or so, or 100 Hertz, sorry, 100 Hertz because it's doing both waveforms. So 100 Hertz comes through here, 100 Hertz, and this is a phase detector, so it senses the phase, and if there's a phase error, amplifies it through this and comparator, and then that controls the clock frequency. So this is what locks it to the line frequency, is this thing here, this section. So yeah, that's how it works. Do I change it? I mean, it's very, very unstable. You know, the basic last two digits of the Solitron are generally untrustworthy. I mean, it does get points where it does stabilise, but it does tend to drift. So I think it may not be responsive enough. I'm not sure if the line frequency is changing too quickly, and so it's not actually responding quickly enough to be able to counteract that in order to reduce the noise. So I'm not quite sure what's going on, or maybe it's just not a good lock. Or maybe this part is faulty, it's not oscillating reliably. I don't know. So I'd always like to try and get the noise down on the Soldatron. So that's why I've got all these different options to try. And I could do a standard oscillator, which won't be as accurate as a TCXO. TCXO will at least be consistent. I mean, the standard oscillator there, which I've got, is in there somewhere. That small square one, anyway, this little square one. That was like 80 cents. 80 cents. And the TCXO there, I think that was about $10 maybe, $5–10. These are in dollars, this is not US dollars. This other board here, I think that was about 30, and I think the other was about the same, $20 or $30, something like that. So I've got a range of things here to potentially try. I mean, I might just put the first one in and find it works fine. No. Anyway. So yes, I'm definitely tempted to look at that. If we do decide to try and open the packages up, I'll try and string out better so you can actually understand what I'm saying. If you do a Soldatron, I don't have to open up those packages because they won't apply to that, because it's either the Datron or the PCBWay project, which I'll be doing for that. So don't have to open those up, don't have to do my bag at the same time. Itchy eyes. Right. Should we pull a Soldatron apart? Yes, pull a Soldatron apart. Let's do that. Let's change views on my touch deck. Touch deck. Stream deck. Maybe you can't touch deck now, am I? Do that. Or should we do... No, actually I'll stick it on. I'll leave it on 4-way for now. The left one's HDMI input, which I'm not using, which is for the other camera I use for normal recording. Smooth these out of the way. Let's get this down. I need to make some more space on my desk first. Does that count? Don't fall off. The pole's getting a bit wonky. Okay. Right. This is annoying. It's when it's soldering on, that's where it's kind of sitting. Didn't really help, did it? Right. Up with the camera. Let's open this thing up. So inside this metal box here is where that board is. hardest thing about this board is actually getting it back in again afterwards. Because it's got some little fine pins in there and some little small sockets which it all has to line up to, and it's a bit fiddly getting it back together. There it is. And I just dropped a washer. Where did it go? Must find that. It's right here somewhere. Where are you? It's right there somewhere. There it is. Right. More magnetic screwdriver, so I can pick it up. Right there. So, there's the original board, which you probably won't focus on because it's, you know, a Logitech camera, so it doesn't want to focus because it never does. Anyway. It's got a very, very touch adjustment. You just move it even a little bit and it changes the frequency drastically. It's extremely touchy, which is why I'm thinking this is potentially a problem. Yeah, but at least the pinout is actually marked on here. 5 volts, 0 volts, control line. Fortunately, it's not marked on the other board, but it's interesting. The actual board down here on the unit, it actually has a footprint for this circuitry on that board. So I'm not quite sure why they decided to make it plug-in. Maybe it's because of the optional crystal oscillator. I don't know. So it makes you wonder if the crystal oscillator is better. It's a bit weird. Someone want to look it up? Datron 7061. Crystal oscillator option. Why is it, you know, I don't know. Why have they got both options? If I would have thought this would be a better option than the crystal oscillator, but could be wrong. Anyway, so yeah, with those 5 points, or 5 points, 3 points, we can hook up a TCXO and see if that works better. I might just do that one first, to try TCXO first. Okay. Hit the like button. Yes, indeed. Thanks, Fred. Everyone hit the like button. Yeah, it's a bit annoying. Oh, not annoying, but it's unfortunate that Clive chooses to stream at the same time I stream. So it's a bit, sometimes a bit of to and fro between the two, isn't there? Anyway. Alright, TCXO. We'll try that one first. Because it's the simplest option, it might be fine. If it works with the TCXO, why go any further than that? I can even get a board made for this, couldn't I? In fact, I think I do have a board for these. Yeah. I can't decide what board it is. Not sure which size I'll be out for. Let me check. Where are they? They should be in this box here somewhere. Here we go. Ah, that's a shame. That's a shame. See, I have a board which I designed, which is in here, for using with oscillator modules, but unfortunately it's the square footprint variety, not the rectangular one. Well, that was silly of me, wasn't it? Though, could I still use it? Let me get one out and see if I can still use it. Come on, let's try and close the box again now. Right. Might still better use it if I'm lucky. I actually think, I remember when I was designing this board, I was thinking to myself, should I allow for both footprints? But at the time, the thing I was designing it for didn't require both footprints. Come on, focus on it. Yeah, kind of did for a second. Anyway. It's just basically used for mounting the oscillator. That's all it's used for. I designed this in 2017. I'm of course assuming the footprint's the same. Would be the same, wouldn't it? That's true, Dave, actually. It's closed streaming, keeps the riff-raff away. Yeah. Right. If it fits that way round, oh, I might get away with this. Assuming I have this footprint right for TCXOs as well as standard oscillators, I'm not sure they'll change. It'll just fit. It'll just hang over the edge like that. I could say might just work if it's correct. Yeah. Not ideal, but I think it'll work. So I need to check the pin out for these T6Os. Always like to double check because I never remember them. Now I've got to find them. Where is it? Could be anywhere. Not that one. Come on, someone tell me the pinouts. Someone point to the pinouts. It'll be far easier that way. Oh, I found something. Is this it? No. No, that's not the right one. I think I might have got it. Hold on. This sort of thing I should keep. I do have references to things. Hopefully. I do try and make notes about that. This is not what I'm looking for. And that's not what I'm looking for. That's not it. Come on, where is it? That's not it. Those super sound ones. Nope. Lots of wrong ones. Nope, that's an 060. I'll check the chat in a second. Here we go. 5-volt oscillator. I imagine it'll be the same pinout as a T60. Let's do some verification by looking at the casing. Pin 4 appears to be ground. Well, will that be? Will it be 8? Effectively, because it's like a dip package they use, isn't it? Seven. 14 pin, is it? 7 ground, yeah, that makes sense then. Okay, I think we're good. Make sure, yeah. Okay, it looks like it matches. So I've got a footprint. So output and VCC. So pin 1 as VCC. Is that right? No. Supply is pin 14. This might be different. Actually helps if I turn the crystal around and face it the right way. Okay, so now even that is not right though. Really? Why am I struggling with this? One is no connection, 14-inch supply. No, this pinout's different. But if I can get I can probably still use it, I'd have to ignore the markings on the board. Let's check the chat. There could be different footprints on the way. Right. Oh, okay. Catch that as Fred. Thanks for dropping by. Alright. I wonder if T6I's got a different footprint. I need to go and look at this. I'm just not sure about this footprint. Maybe there's different ones. It's odd that what is on this diagram also doesn't quite match the pinout I've got on this thing, so there might be a different variant. Let's go back to the listing of this thing and actually find it. Hopefully it's actually got the pinout in the listing. That's what I'm hoping for anyway. Just want to be sure I get the pinout correct, otherwise could blow it up. Come on, dude. It's going slow for some reason. Can't think why. It's not like my internet connection's busy or anything. How's the quality look anyway? Is it looking okay with the lower bit rate I've got? Because it's less than what it should be. YouTube recommended a certain rate. I was actually below that. I might just increase it very slightly. Right. So I'll find this bloody part and get the pin out once and for all, so I know exactly what I'm dealing with. Which one is it? I've got two here. It'll be this one. No. Hold on. That's curious. Because the ones that showed up from last year, and I only purchased it recently, so that's weird. I'm pretty sure I got it from AliExpress. Pretty sure. No, those are the wrong ones. Maybe I got it from eBay then. Maybe I did. No, it's not from eBay either. Okay, that's weird. I did a search for frequency, then I found it. Go figure. Right. It's not listed as a TCXO. Oh, the page I've requested isn't findable. Great. So I can't reference the page because it's gone. Let's find another one. It's a... That's what I should do actually. It's a Rohde brand. I should just look at the brand, shouldn't I? Should look up the specs on the brand. I didn't think of that. Okay, I found a different listing. Same branding. Yeah, okay, so the pinout here is matching. Right, so that's the same. All good. All good. I'll maybe drag this up here so you can see it. Okay. Here we go, there's the pinout there, which is the same I was getting in the data sheet I was looking at. Or the information sheet, so. Yes. No connection. Ground, output, power supply, or voltage control. So I'm not using that. I'm planning on using that anyway. So yes. So output is pin 8. Yeah, this doesn't quite work with my board, unfortunately. Let's put it in upside down for a start. So pin out's output, pin 7 is ground. So if I treat that as ground instead of VCC, well that's dodgy, isn't it? Reverse polarity. That could work. Or do I use the... oh, no. Not liking this. You know what? This is not didable. Let's do this differently. Did I leave that especially open? I think I did. No, I didn't. It's gone. I closed it. No, closed it. Okay. Right. Yeah, ground distance is the case, yeah. So, yeah, unfortunately the pinout from my little board here doesn't match the pinout from this. On one end, the end's actually different. Because on my board here I've got a VCC and output side by side, which is interesting. It's the modules I use, it's some custom ones I had made. Custom frequency. But they're different. Pinout, obviously. The pinout, it doesn't match on the same. It's a shame. So what I'm going to do, I think, is use some Dupont connectors. How does that sound? Because I'll just plug them in and make sure I get that right. I think that's the plan. So let's try that. Once I find them, I'm probably going to drop a whole bunch of stuff on top of the Circuitry now. Okay. A box of stuff in here. So I think the female DuPonts should actually work. Let's see if I can find some which already stripped off, which I don't need to replicate. There's one. Right, well, yeah, so let's strip those new ones off. Let's see if they fit. Well, it fits on the pins of the ACXO, right? Or TCXO. Do they fit in here okay? Yeah, they will go on there. So that's an option. Let's do this. Right. So your VCC is that pin. Ground is that pin. And so that one is the output. Right. There was a pin out on here. Where the pins gone? I've lost the pins, can't see them. There. So that one there's the output. It's 5 volts. And that's ground. Right. That can float in the air, it'll be right, won't it? Yeah, it's fine. Okay, let's power this up. Is that running? I'm not sure that's running. Well, no, because I've got filter and stuff turned on, I think. Yeah, slow. Turn the filter off. Okay, it seems like it's working. It's. I can do this. And we'll use this as a source. Hello, George. Let's go to list. Oh no, I want to keep it on 7 digits actually. I don't want to keep it on 7 digits. Let's turn it on. Let's turn this off so you can see the display a bit better. And zoom in. See 10 volts. You filtered out, you can't see the angles very well. Here we go. So it's going to be a settling time there. It will be drifting, so it's going to be hard to judge initially. I probably should put a top cover on actually. That's floating around inside there. Right, might leave that going for a little while and see what happens. Yeah, the soldering line's right in the way, isn't it? Interesting way the display disappears. That's freaky. Alright. Yeah, let's do it this way. It's weird the way that display disappears. I can see it, the camera can't. That is odd. That is really strange. Because it's going to be reflecting around, of course. Well, we'll see if it does anything. Leave it sitting there for a while. But that was weird the way that the display was half disappearing. It's almost like it's like a frame rate issue or something like that, or shutter speed. Don't know. Very weird. If I turn this back on again, what happens? Yeah, I don't know. Anyway. Okay, Sheridan, thanks for dropping by, mate. Hope you catch you next one. So yeah, we'll leave that running for a little while, see what happens. Obviously both of those things are stabilising. It'll take a little while to drift and settle down a little bit, but as you can see there, it's jumping around a little bit, which isn't drift, that's just noise. Yes, it's just kind of noise on those last digits, which is what I'm not happy about. Can you still see that reading there like that? What do you want, George? George wants to be famous. Yes, anyway. So can you still see those digits there or not? I can't tell from my screen because I've got it all shrunk down so much. Might be too small for you in that view. It's definitely still drifting in the downwards direction. It'll do that for like an hour or so. What's the thing that's causing the glare on there? It must be the windows. But as you can see from that last digit of jumping around, it's not awesome. I'm trying to see if it's any better or not. I can't really tell. Not until it settles down, at least. It's a bit early to say. Small but readable. Yeah. Do I crop this a little bit? Digits are readable. What I might do is try and crop it slightly and try and get it so it ends up being a little bit bigger. So if I say crop 20 from each side. It's not a big amount. I suppose it depends what screen you're looking at. And if you're on a mobile phone, you probably can't see it. Or there's always no. I don't have a desk zoomed with the other views I have. I don't really have that. Can I get this better? Come on, I'm not happy about this. Hopefully that's slightly better. Hey Ian, how's it going? That's good timing, look what I'm using. Actually, it occurred to me yesterday, when you sent me that metal casing for this PDVS2 Mini, I don't remember if I did a video on it or not, or mentioning it to anyone that you actually made the upgraded case. I don't remember if I did it or not. Because no, you know, originally you sent them with the plastic cases, and then you upgraded to the custom-made metal cases for them. Did the upgrade on them, so I wasn't sure if I actually mentioned them. I probably did do it, but I don't remember doing it. That's not unusual for these days, though. I don't remember a lot of things these days. I need to go this way more. think it did. Cool. Good. Good. I was just thinking, I don't think we're doing it. Yeah. How's the new one going? Has that made any more progress? You better source parts now, or not? I think you're still waiting for parts, weren't you, last time? So you're still getting like a 4 to 5 count jumping around there. 4 to 5 counts. So Ian, what I've done on this is the obviously a Datron 7061, and I've swapped out the original board with a TCXO to see if it reduces the noise. You know, you get that these things are renowned for having noise issues. So I'm just trying to replace the original oscillator board, which locks it to line frequency. And I'm just trying to see if using a TCXO or some other module instead will actually replace that and get it less noisy. I've only just turned it on though, so it's all settling down, it's all warming up, you know. It's going to take a little while to settle, but it's still drifting quite a bit yet. Good up and going, but it's a bit expensive, is it? Well, just try doing some, see if they sell. I mean, I don't know. If you, I don't know, maybe it's sort of hassle for you, I don't know, but I know parts costs are going up as well, so it wouldn't surprise me if that's got to be a bit of a problem, being a bit prohibitive costs with the parts required. You could try it. I mean, if you're making a margin on it, you know, a profit's a profit, isn't it? Unless it's going to eat into your other items, which are more profitable, I suppose. But you could just try it, see if people buy them anyway. I'm saying that for my own self-interest, because, you know, I'd like to get hold of one. Anyway. So we're down to now 189, 187. 185, 192, 187. So there's that noise thing going on there. So I'm not sure the TCXO is doing the job. It's obviously working. It's obviously, you know, oscillating properly and working. Otherwise, it wouldn't be working at all. Because if that clock frequency isn't there, it kills the clock completely. So if it's missing, it just doesn't work. So the T6O is obviously working, but it's not solving the problem with the noise. I'm not sure if it's better or not though. I think it is probably slightly better. But it will be hard to say until it fully warms up. Once it's warmed up and it stabilises temperature wise, then I'll be able to tell a bit more easily. But right now it's drifting as well, so yeah. I don't remember what the setting was on the output on this PDVS2 Mini. What the calibration point was for that. I think it was slightly over 10 volts. I'll have to look it up. Old stuff. 10.000006. Right. Was that 6 microvolts high? At the time of calibration, I mean, that's a while ago now. It could well have drifted a bit by now. Don't know. So that's what we're trying to target is 10.000006. We shall see. It seems to have suddenly done a correction because these do a periodic correction every 15 minutes or so, and it's just dropped down by a lot, so it's just got an extra 0 there. Come down by about 90, I think. So maybe the next correction will be a bit closer again. I actually think that's slightly better. Now it's done that correction as well, it's behaving slightly better. Still drifting by quite a bit, but yeah, I think the TCO's improved it. T6Os does seem to improve it. Where's my other window gone? I think I've lost the window. Here we go. So, Ian, what do you think the retail price would be for that other version? Obviously, you've probably sat down and worked out what it's going to cost you, but what would the retail price would be for them? I mean, do you think it's going to be too much of a difference to make it feasible or not? Obviously, you think it's not feasible, but I'd just be interested to know what the actual your estimated retail price would be for them if you were to go ahead with it. Yeah, but it's going to be too big a step for the improvements you've made. I don't know. Did sound promising though. £100 more. Wow. Yeah. There's probably very little we can do about it either with the requirements. Be a hard thing to try and cost cut, wouldn't it? Just watching that number bouncing around. It's changing right now within about 4 counts, which is not actually too bad for this thing. Sometimes it jumps by 20 counts, so 4 counts is pretty good. Still more unstable than I want it to be. But the T6O looks like it could be a goer. The other thing we've got is this. Which one should we use? We've got this tunable TCXO. We could try that. It's basically the same thing. On 44p, can't see what you're doing. Yeah, okay. Doing a car. Yeah, there you go. Zoom view. So this module I'm looking at now is also a TCXO. It has a control circuitry on it which does compensation. I believe. Got an awful lot of supporting circuitry on it if it's not doing compensation. I'm just looking at it now, trying to remember what the hell it is. Ground. No, it's got 2 ground connections now. No, it doesn't have tuning. So what's all the other circuitry on there for? That's weird. What's that doing? I'm trying to figure this out now. I think it's buffering the output or something. Maybe that's what it's doing. It's buffering the output. Yeah. So that one is not what I'm looking for. So the green board, which is one I showed you before, which has got the SMA output on it, that's why it's looking like it's possible. So it's very similar circuits, almost identical circuitry. Well, it's the same chip and everything, you know, same topology, but it doesn't have the amplifier transistors on the output, which might mean it can't actually drive properly. It might not be able to drive the output. Yeah, I don't know. Stability is not too bad right now, is it? It's not perfect, but it's not bad. Considering we are looking at microvolts. With no filtering. Oh, the guy's jumped into 36 there. Yeah, it's because you're working this way closer. Yeah. Anyway, I might just leave that going for a while and see what happens. But so this is the other module I'm thinking about trying to implement as this one. But again, it doesn't have the output amplification there. So I'm not quite sure what the output from this chip actually is. Maybe the drive isn't high enough to actually control, to go through those buffers and give decent signals. I'm not sure. Yeah, I mean, I was looking at that system there. It's got a current mirror. Yeah, it's using a current mirror. Pretty sure that's what it is. Interesting. Right. I don't know. I'm tempted just to shove this thing in and see if it works. I need to do an SMA adapter, or maybe hook on with a wire or something. Actually, I might be able to shove a Dupont cable into that. Will that work? Yeah, kind of. It goes in, but it's a bit loose. It's not a tight connection, it's just wobbling around in there. So that's an option. I could just stick the Dupont in there and plug on with that. That'd be pretty easy to implement. It would need tuning though, because it's an oscillator, so it will need adjusting. I have to get that on a scope and tune that and stuff like that. But and that's when it changes place as well, because it's doing a loop. It's a bit harder to get right. I think there was a specification of the voltage you set it to, I can't remember now. Yes, the thing with T6O, yeah, it's not line locked, which is the advantage of the original circuitry. It's supposed to be line locked, but it seems really erratic and noisy. You know, just trying to measure the frequency, it's just, the jitter on it's incredible. It's just constantly changing. Every cycle it's just all over the place, which makes you wonder if maybe it's a bit dodgy. Which is why I got this board, which is basically the same circuitry, just a new version of it, just without the amplifier transistors on the back. So let's go, these transistors up here doesn't have this. It's just the output from that goes straight out. It goes through a capacitor, or capacitive coupling. This doesn't have capacitive coupling. So on here it's got this, I think it's a current mirror, is it? I'm not sure. and then this is the actual drive transistor here, which is pulling down when it's activated, so it's pulling between plus 5 volts, which is going through resistors. Interestingly, not really filtered. And the 0 volt rail. So it's basically pulling between there at 220 ohm. Pull the thing up and down, that's basically what it's doing to create that waveform. So it's like a, might be wave shaping or something, I'm not quite sure, but anyway. Maybe it's trying to make it a sine wave or square wave or something. I've got no idea. I haven't probed that part of the circuit. But I could just try hooking this up and see if it works. Again, Dupont cables plugged onto the pins. VCC ground and the tuning voltage are there, so I can definitely hook those up to there and play around with that. But yeah, so I'm not sure if it's that oscillator section which is causing the problem with the instability, or whether it's the phase detector and comparator section which is causing the problem, which is down here. Because as it comes through, you got the AC comes in, as I said before, comes into this comparator section, and then we've got the frequency from this comes through into this section here, which is a divider. That's what divides the frequency down to get down 100 Hz at the end. So if you have 100 Hz, came both of those. And whether it's something here which is potentially noisy, I don't know. Yeah, it may even be this compensation which is up here. This compensation chip. Could something do that. But I'm leaning towards the oscillator because it's so touchy. The slightest little touch on the adjustment can, and it just jumps off frequency drastically. It's a big change. So I'm thinking it's just way too touchy, which is why I'm going to get a new one, and maybe they'll be less sensitive to change. Maybe it's just too touchy. It's just changing by too much. Anyway, that's why I've got lots of different options. Try different things. But at least I know TCXO is going to basically be a consistent, stable frequency. It shouldn't shift around. Well, the media's getting better. It's obviously getting towards its temperature. So it's just here. Go back there. Here we go. It's getting pretty close now. I don't know what the upper level is of that board. It's whatever that chip can drive. That was it, MC1648P data sheets. I would have saved this one. I've actually purchased some more chips as well. I've purchased some spares, as I always do. So I think, have they arrived or not? I don't think they've arrived yet. Just in case it's a bad chip. There you go. Shove this in the top window. You probably can't see it like that. I don't have a button for just the top screen. Oh, I've got that one. I have to. Okay. I'm not sure what it says. So there's a diagram for it. So it's basically going between VCC and buffered ground. VCC1, VCC2. So you can actually have it pulling higher. It's got a separate input for that. Is it showing a pinout? Yes. VCC, VCC. So. Calls it 1 and 2, but I don't differentiate on the diagram for the pinout. Oh, there we go. VCC1, pin 1, VCC2 is pin 14. Let's have a look at the board. The frequency jump back up. It's back up to 35 now. So we're looking at pin 1 and 14, wasn't it? 1 and 14 are tied together on this board, so they're both the same voltage potential. And the new board let's just leave out a packet and get it out. And the new board, I can't tell. Can't see on there. Might have to measure it. I'm guessing 1 and 14 on this board are tied together as well. So this board's actually got an inbuilt voltage regulator. It's got a series regulator in there. Trying to get the light on this so I can see the number. Can't. Let's get the microscope. 78L05, that's the regulator that's on that board. So it means I can put more than 5 volts in. But it probably means if I put in only 5 volts that the supply to the chip is going to be dropped down. Actually, while I've got this microscope on, see if I can see any of this chip. Not to measure it. Yeah. 1 and 14 you connected on this board as well. So no difference in voltage potential there. So output from the board. So it looks like I can go between VCC, which is 5 volts, and whatever that resistor value is there. Don't know. Does it say what it can go to? Upper voltage? Doesn't look right, does it? Not sure. Why is it saying like, oh, 0 would be, you know, just over 3 volts? Must be going lower than 3 volts on the output, surely. Anything else in here? Just negative supply. Mind you, also has a series capacitor on the output. So it's purely a frequency output, not really a voltage output, I suppose. Just trying to read and find some information about the output. I'm skimming through, obviously, so I'm probably missing stuff. Don't know. Don't know. Maybe it does need to have that switching, but because it's not pulling down, it's pulling up. So it's interesting. Anyway. Let's jump back over to here. So I did jump up to 35 before NAS. You see instability there. Jumping around. It's this kind of thing I'm trying to solve, you know. It's just that makes the last digit or two useless pretty much when it's this noisy. So the TCXO does look slightly better, but it's still not great. I guess it depends on what the line frequency is doing at the time. So I'm actually wondering if maybe the feedback loop, which is doing all the comparison, is too slow. Or potentially too fast. It could be either way. I thought too slow would be the issue though. It's possible when it's getting divided down it's too slow. It's only 50 Hz, it's not like a big frequency, it's not super high frequency or anything, so it should really be fine. Maybe the control voltages are too extreme on the actual original one. Maybe it's drifting by too much and it's trying to pull it too far. Or it's not pulling it far enough. Lots of maybes. Yeah. So not quite sure what to do about it yet. Just checking the mics, my phone has went off. That's fine, nothing that can't wait. Oh, got a new Patreon. Cool. Garth. Garth's a new Patreon. Cool. Hope he drops in. So there you go, it's shifted down again a bit more. So yeah, this is why I'm going to solve this noise problem. Mind you, that's without the filter on, but I'm trying to actually show what it's doing rather than hiding it. So I don't have the filter on. But I see how much it's changing by just in a short time. It's like 10 counts different. Whereas my Datron 1082 is changing by 1, maybe 2 counts the entire time. This will be doing this sort of thing, you know. So it's the the Datron 102, even though it's got the wrong crystal in there, it's not the right one for the line frequency, it's more stable than this. Go on, get a 0. Go on. Anyway. Yeah. Yeah, I think it is slightly better, but it's not great. What I should probably do is put the original wall back in, and you can see what that's doing. Yeah, they've got enough experience with this to see what it's going like. Obviously, it's still warming up, but I'll put the original wall back in, and you can see what that's doing. Probably should have started out with that in the first place. And we'll go from there. Let's kill power here. Now the hard bit's getting this back in again and getting all the pins lined up. It's very touchy. Now I'll say that, of course this time it drops straight on. Of course it does. Let's put a mounting hole on so it's definitely earth through the board mounts properly. Like it's supposed to be. I won't put the other screw in yet. I'll put the cover on. So this is like as good as it's supposed to be. Alright, let's see what this does. Obviously I've upset it, so it's going to be jumping everywhere. Right, can I look at 2B402, 403, 404? Where are they? So that's the comparator inputs and the control output we're looking at. That I could do. I guess you think about the phasing, aren't you, and looking at the phase inputs and seeing what it's actually doing with that signal. It's interesting the way the voltage has dropped down by a lot. That's a big difference there. That's by taking the covers off a little bit. I also want to see what the stabilizers to first, and we'll go from there. I might pull those test points up. I also want to let it settle again first. But you can see this is noisier. Sometimes it's better, sometimes it's worse. So you know, there you go. Drop down by a lot then. So yeah. I suppose your thinking there is that we can see what the phase difference is between those two inputs, and see what the comparator is actually doing to compensate for that, and see if it's changing as it should be. I mean, there's no reason why we can't check for that. But what I was seeing when I was doing testing on this previously, was a lot of jitter. I was seeing so much jitter on that frequency, it's just a mess. So I was trying to determine what's going on there. I think I was measuring, where was I measuring? What's that test point? I think I might be looking at the output of the actual oscillator actually. I think I'm measuring there. I think I did hook up to TP404 at one point. So that IC426 is a 4046, I think. So it looks like. And 4046, I have it on my wall here somewhere. It's a POL. Interesting. So it's using some of a POL in order to do the phase comparison. Let's go back to here. I'm not sure what pin that is, so you've got a signal in, it's like 14. An output, I don't know what that is. Let's look at the pin out for the device. Um, 14 is frequency reference. Frequency in is pin 3. Output to VCO is pin 4. Lock is pin 1. So VCO output pin 4 is likely to be the one it's using. I don't know, is that 13? No. '13 is OPC2, whatever the hell that is. Not sure. It's not the best diagram. Wish I had a better one. So it's using the clock we're generating as the reference frequency. Comp N. Wish I knew what pin number that was. I could probably trace it if I needed to, but I'm not that worried. Yeah, I wish I knew. OPZ, is that? OP2? Is that what it says? Phase comp OP2. So OPC2 is pin 13. That does kind of look like 13 on the screen, so that could be correct. Yeah, I'm not sure. It's an interesting setup. Wish I could read it slightly better. Yeah, I was looking at that's one of the things I had thought of, was injecting my own voltage for the VCO, so that it would actually hopefully just have a fixed frequency for net voltage, because that works and at least you eliminate the VCO being unstable. But I think just from how touchy it was trying to do the adjustment on the slug, it was just so touchy. You move it a little bit, even just touch it, it jumps off by heaps. It was a big change, even just touching the inductor at all. It was really, really hard to get right. You know, you can change that thing by a megahertz easily without hardly even trying. So yeah, it's definitely a little bit challenging. Let's have a look at it now, see what it's doing. So let's see how stable it is now. Yeah, see, not very stable. So you can see that the T60 is giving more reliable results generally. See, it does kind of behave okay, then it goes out of whack and comes back, and goes out of whack and comes back. See, what I was kind of wondering is if maybe the control voltage coming out is just too excessive. It's maybe trying to pull it too far. Don't know. Could be. See, when it's kind of okay, it's fairly stable. Then see, it will jump off and go a bit wacky. Then it will come back and be okay again. You know, within a couple of counts. Just watching it now. But yeah, I mean, T60 is definitely more stable than that. So I'll just put that in there to be an upgrade. But yeah, having it locked to the line frequency, which is what it's supposed to be doing, is definitely a better option. So I don't think I'm going to get any better on that right now. I mean, it's changing by 20 at the moment. Like I said before, it's changing by 20 quite commonly. So what I might do is hook up this other board and see what happens, just without any amplification, just straight out this board, straight into the actual circuitry, and we'll see if it does it or not. Okay, thanks Dave, catch you later mate. So where do I put the T60? Here it is. Let's use the same wires from this, or some of them anyway. Ground, PCC, I need a control line input, so I'll use that one for that. getting this right. Yes. I'm just going to leave this one hanging outside the case because this one's likely to flop somewhere and short something out. See if it even works. May not. We have nothing. Why do we have nothing? Guess it doesn't work. It's not clocking. Did I do something wrong? Double check. 5 volts, yes. Ground, yes. Control line, yes. Output, yes. So I've got the correct connections, but it's not clocking at all. You've got power over here, but the CPU is not running, so that's not giving a good enough clock signal. It's not doing the job. Let's just hook a scope up and actually see if we've got a frequency coming out. Still screen capture. I should be able to do a screen capture if I remember what a scope ID is. I always forget what it is. Okay, found it. It's shove that up there. You can kind of see, can't you? Do we get anything? Got a big DC offset. Do AC coupling. Well, we can't get 131 megahertz. Well, that's not right, is it? Okay. Let's give us a tweak. I'm going to screw over it. Got my profile out. Makes it hard to do it as well. That is right out. This has completely wrong frequency. This board is not doing the right frequency ranges. Well, that's bloody helpful, isn't it? That would work if it was too high. Don't never lock. If I take the correction voltage off, in case maybe that's the problem. That's lower. But still very, very high. It's too high. Yeah, I need to look at the design of this board. It's obviously resonating at too high a frequency. So that ain't going to work. Yes. So this board here is a no-go. At least not until I modify it. Probably just needs a small capacitor shoved somewhere to help dampen that core down a little bit, make it resonate a bit quieter, a bit lower. Now I pulled the resonator off this thing, didn't I? All these pins are loose now. Why are they loose now? I think. Shove that on there. Shove that on there. Shove that on there. Is it right? No, all these are falling off now because I've stretched for bloody connectors. Yeah. Let's get some more. I'm actually wondering if I can use the compensation voltage on this as well. Maybe I'll try hooking that up, see if it works. What was that pin out on this thing? I've bloody forgotten it. Pin 1 wasn't used. Pin ground and that one and that one. What the hell was the pin out again? I've forgotten. I think it's spied a small static flash when I connected the first cable to the main board. Well, I hope not. Let me see. Pinouts. I've forgotten what the bloody pinout was now. Okay. 7 ground. 8 is output. 14 supply. Okay. I took up a pin for the control voltage, see if I can actually get it to control it. Just in case it actually has a compensation option on this one. It may do. If it doesn't, it doesn't matter. We'll do nothing. Come on, push on. Right, let's do that. That's a bit stronger. And you can't currently see it. Because I've got the thing in the way here. Which one do I want? I want that window. Okay, so that's a much stronger output from the oscillator. It's doing a lot better. I mean, the output from the other ones are really, really weak, so it's probably just the output wasn't driving enough. Probably can't drive enough current, maybe, I don't know, but yeah, so that's probably why the circuit, the original one, has the amplifier circuit built onto it. It needs it to drive the levels that's required. So, are we getting much jitter on this thing? No, it's looking pretty stable. Though the frequency down the bottom there is showing up as jumping around a bit. I don't know. It'll be a calculated frequency anyway, so could be a thing to do with the trigger point. It's possible. But the hardware frequency counter is showing a stable frequency, so I trust that a bit more. So it doesn't look like it's actually doing any compensation. If I hook onto this and do DC coupling again. There you go, look at that. 50 Hertz is putting spikes out. There's a compensation happening. Just trying to find the frequency. So it looks like the phasing's not right, it's shifting in phase. But it's a fairly consistent shift. Oh, looks like it's locked there. Looks like there it's in phase. And I set on 16 for a bit. Oh, sorry, 76. Drifting off again. I'm just trying to watch the display of the meter and the waveform from the phase detector. See if I can see a correlation between what it's doing up there and what's going on the screen. Doesn't really seem to be a correlation between the two. Not that I can identify anyway. Well, I certainly hope that wasn't a static flash. I mean, it seems to be working alright. I haven't done any damage if it was, but I shouldn't have static build up here. Yeah, I'm wearing cotton clothes, cotton socks, my anti-static work mat, grounded gear. It's cotton. Oh, it's not really cotton, is it? It's not a artificial carpet I've got either. It's a consideration I had when I put the carpet in as well, is to not have static build up from that, so it's not nylon or anything like that. Any plastics in the carpet, so doesn't mean I won't get static build up, of course, but those things help to reduce the chance. I don't know, you see any correlation between those waveforms and that display? Interesting, there's nothing there. It just disappeared. Does that mean it's in phase enough now to be okay? So that just changed by 5 counts and the waveform didn't show up at all. Curious. How's about the waveform not being in now? Why has that disappeared? It's either perfectly in phase, so it doesn't need to do anything, or something's gone wrong. I see some little bumps in there, which are coming and going, so maybe it is fine. It's probably just perfectly in phase moment. And the noise is still there, so maybe it's not all that issue. I think that is part of the problem. I'm pretty sure that is part of the problem with having this clock, but it's not the entire problem. Mind you, noise probably doesn't help the fact I haven't got the cover on it right now either. Makes it a bit less reliable. There we go, this spikes again. Okay. So even when it is out of phase, it's not actually that bad. You can see the corrections are very minor. So just having a fixed frequency, I think, is probably okay. I say as it suddenly starts to require more extreme adjustment. Because that waveform has a reputation about the phase difference, so the bigger the waveform, the bigger the phase difference is between the two. But if it's not like rolling continuously by a large amount, it's not that far out. You're always seeing there's a slight drift between the phases, which is why sometimes it basically stabilises where they are in phase. Like right now, it's stabilised. It's just slowly drifting now. So there's not much in it, really, to be honest. I'm really inclined just to leave the TCXO in there. I really am. If it's just rolling like that, but 10 times faster, then yeah, it'd be a problem. But it's not really much. Yeah, I think I'll put a T6O in. So I'll put the original ball back in again, and we'll look at what that one does. In you go. So this thing I was saying before about being fiddly to get back in place. There we go. So I hooked the probe up from the scope in exactly the same way. Well, I'll leave the cover off this time so I can see it. That. And that's what the VCO is doing. Let's get the trigger point a bit better. We see how stable this is. At the moment it's actually looking better. Curious. It does that. It looks pretty good. It looks like it's under pretty good control. I don't know. Now I'm torn. When I was looking at the readings of the other unit, using the TCXO, the readings look more stable. But when you look at this thing, it looks like it's under control and it's actually locked properly. Am I worrying about nothing? Maybe just leave the thing alone? What do you reckon? Oh, eBay. Oh, I was saying I'm washing, which is too expensive. It's closing soon. I mean, yeah, it's looking fairly good there, actually. I can see the width of those pulses changing, but that's normal because it will be adjusting itself to match the line frequency. That's getting really close to flipping over. It's getting really narrow now. So I might need to adjust the frequency a little bit to make those pulses a little bit wider, just to give it a better ratio there. Let's give that a slight tweak and see if I can mess it up. It's like the average voltage has come up. Go the other way. Yeah, it's flipped over now. I need to monitor the frequency as well, don't I, really? So if I look at the frequency output instead, just here. We're not on the frequency we should be on. It should be compensating anyway as I adjust it, and it is doing that. Just there is looking like it's out of control. So let's look at the phase detector output, or comparator output. Bring this back down again. Yeah, that's just wrong. Yeah, so let's bring this back the other way. Get the pulses back where we want them. So I think what I kind of need to go for is a... Come on, fix yourself, there we go. I think kind of where I had it before was probably about right. Because you've got a fairly decent average waveform there for the actual lower end. We're looking at there, 2 volts division, so it's about 2 volts, about 1.8 volts or so at the bottom there. Probably says it there somewhere, yeah. Yeah, base 1.73. So actually, I think it's probably doing all right. Ready? Let's play this a bit more. Base is now 2. Obviously, it's built-in filtering causing that base voltage offset. Come on, camera. Here we go. I'm just trying to get a lower base voltage and a longer pulse, so get more of a control range. That's 1.4 there, so okay. That'll do, but that's looking alright really, isn't it? Oh well. Why am I seeing 20.106 volts on there? That's not right. Hey Christian, how's it going? Why is it saying 20.106? Because I'm not injecting 20 volts into it. Maybe I've confused it. It's probably got latched up with the clock frequency changing so much. Let's reboot. Here we go. Yeah, here we go. That's better. So I think I might leave it there actually. I mean, that phase detector output is looking fine. Really. I mean, maybe I was worrying about nothing. It looks like it's under control. Or at least on the loop. I mean, there could still be big phase differences. It could just be it's reacting too slowly. It's fairly slow to react. Yeah. I don't know, because when I was looking at stuff before, it was looking much more unstable. In the waveform, I'm not sure about. It's not a particularly nice waveform. Mind, you could be doing my probing as well, it's possible. I'll probe over here instead, does that make it better? No, not really. But you can see that frequency isn't actually 49.152. That is jumping around. I don't know if you can see it on screen or not, but it is jumping around slightly. I go back to this one. Just up here, this frequency just there, it's constantly changing. And you can see here in the waveform there's jitter. I mean, you will expect to see that frequency changing all the time anyway because of the correction for the 50 Hz. So if the 50 Hz has drifted off a bit, then you will see obviously a frequency change to compensate for that. But it's the jitter I'm seeing which is the interesting part. TP403, 404 I could do. Let's see if I can find them. Before I did, I'm going to tweak this some more, see if I can get with this jitter. Doesn't really look like it. Leave it there. And then upset it again. Okay. Real life test points. 403 and 404. It's 402. 405. Come on, where are they? 303. This is going to be hard, but it's finding you, isn't it? Now, there we go, it's 403. So there's 403 here. No, it was 404. Come on, where are you? Something I did too on this when I was playing with it previously is I replaced the capacitor. I found there's a Phillips capacitor in that clocking circuit on the main board. And I did replace that because I did notice it was not working very well. And it did seem to help with the noise. There we go, this 404. Okay, right, let's get another probe. Interesting waveform, isn't it, on that 404, which is the pink waveform. Hey, Kimmy. Kimmy, hold on. Yeah. No, I'll sleep on that one. So that's TP404 just there with that pink waveform there, which is not particularly great, is it? Why has it got that bloody big downslope on it? It's like a discharge of a capacitor or something. TP404 is this one here. Yeah, that's weird. Yeah, it does, doesn't it? I mean, they're in phase. Yeah, I don't know, maybe I'm worried about nothing. Yeah, that is looking fine. So that difference in between the pink and the yellow waveform, that's probably generating the pulse, which is doing the correction. So that gap there at the end of the waveform where it's on negative going side, that's likely to be the pulse output. So let's have a look. Let's see what we get. Let's hook up another scope. Oh, another probe. Channel 3. Yeah, I might just expand that slightly more. Maybe. Can kind of see it. If I put it above instead, it might be easier above. Yeah. So yeah, that's what I expected to see. Pulse correction between those two waveforms. Okay, Normus, thanks for dropping by. Catch you later. So yeah, that's looking right. So the output pulse correction waveform is looking correct as going high when the pink's coming high, and goes low when the yellow is coming high. So that difference in phase is what's doing the corrections. That's correct. That's what I'd expect to be seeing. It's all looking fine. Yeah. And if I did the same thing with the TCXO, might show a little bit more, but yeah, that's looking alright, isn't it? There's nothing really that bad there. Oh well, I'll put it back together. It's a fun thing to look at, though, wasn't it? It's interesting. P-rolls and VCO is always interesting. I think you are anyway. Let's put this thing back together. Probes away for a stand on or something. But it's definitely interesting the way the TCXO did seem to have less noise than the original oscillator, which isn't what the measurements would tend to indicate. So that's definitely a little bit curious. One thing I haven't done to this meter is recap it. It hasn't had any recapping apart from that one there. The rest of it I think is still original, but they seem to be okay. Some of these caps are really hard to get to though. You have to take the balls out to get to them because they've got a plastic frame underneath them, so you can't actually get to them to recap them. Some of them anyway. There's a couple over here which I'm not completely sure about. They're not bulged, but I'm just, you know, don't know. But can't get to them too easily. But there's no measurements on the power supplies showing any ripple or anything like that, so that'll look fine when I did that testing. So I don't think there's actually anything wrong with it. It's just a matter of trying to find ways to make it less noisy. I mean, I know these do have a trait of being noisy, but surely they weren't like this original. You know, new from the factory, they couldn't have been noisy then. Surely. Otherwise, you know, that last digit or two is completely useless. So I don't think they would have been noisy from factory like that. So yes. Anyway, we'll put this back on the stack. So my Datron 1082 is much quieter. So I think between the two, the Datron is a better meter, to be honest. As far as accuracy, well, stability of the readings I should say, rather than accuracy, but stability of the readings is certainly better. so many power plugs. Right, is it done? So the question is, did I waste my money buying these things? Maybe. Try bypassing the input connector and connecting directly to the board. You mean on the actual input lines from the measurement source? No, I haven't. I haven't done anything like that. But I do know these Cyclotrons do have a history of being problematic with noise. You know, the EVBug forum's got discussions about it, saying that they're noisy. And so I did see an improvement when I replaced that capacitor. I probably reduced it by 10 counts, but it didn't solve it. So yes, it's got some interesting stuff going on there. I mean, you wouldn't think that when they were new, they wouldn't have been that noisy when they're new. So what is different? You know, is it just purely from components aging, and maybe it is maybe a slightly leaky diode somewhere, or a noisy resistor somewhere? Don't know. But I was thinking it was the clock, because it did seem to be. No, when I did playing around with that, it did seem to improve the noise. But yeah, it was weird the way they're having a TCXO which wasn't in phase gave slightly bit of noise. Then the VCO which was in phase. New connector. Which one do you mean? The actual one that's on the lead or the one that's on the front panel? I've tried hooking up to the rear panel connector. I've tried that. Didn't make any difference. So unfortunately it wasn't that simple. I did that really to rule that particular issue out. But it doesn't mean there's nothing else wrong somewhere. Let's put this stuff away. Well, both new and unit this year, it's true. But yeah, I mean, I don't know. There's lots of things going on there which could potentially be a problem. I mean, it could even be the references a little bit noisy. It could be the references aged and maybe it's not great, or maybe the buffer circuitry around the reference is dodgy or something like that. I mean, don't know. Could be a weak coupler somewhere or something like that. You know, opto coupler or something like that, which is not transferring data reliably. Or power supplies are all good. I've already ruled the power supplies out. I've tested all those, checked the ripple on those supplies, adjusted them all as required. Was it just adjustments? I can't remember if it was adjustments or not. But anyway, I've gone through the power supply stuff. That was all okay. So I'm confident about that part. Here's the input circuitry here. Let's pull this up. That's a reference input. That's different. Front input, rear input. I'm going through a switch. So I've tried operating a switch, obviously, make sure the switch is okay in case it's a dirty switch. It's not that. Although I haven't tried cleaning it though. But like I said, I did try both front and rear inputs. It didn't seem to matter. Yeah. Indeed, mechanical does get the most wear and tear. Or did I clean that switch? I think I might have cleaned that switch actually. I think I might have cleaned it actually. I think I might have done. Yeah. But it's got these other. Okay. I was looking at this part of it for something. It's got a relay here, which is a reference input, which was also switched to here as well. So the reference is switched on and off, in and out of circuit. Where do these go? Through there. I think it might be high and low here. Is the outputs which go to the rest of the circuitry just there. So the reference is switched in and out. Switches between the reference and the input circuits. I think I've actually got that reference connector actually. I think I've got that too. Anyway. That was a rather non-productive morning. Yeah. I'd like to have actually choose something. Close that window there. Well, at least the 1080 stream's been kind of okay. It's dropped 3,500 frames. So it's not great. It's only barely doable, I think, 1080p. They can only barely cope with it. So it's a bit borderline. I think I was pushing my luck there to 1080p. I think my internet connection is not quite good enough, really. Not to the sort of level I want to do it at least. So I might have to go back to 720 just to be sure I'm getting decent connections and stuff. You're 3,500 frames. This is 1%, 1.1%. This has dropped. So how many seconds is that? Be 120 seconds effectively. All right. Hold on, let's work this out. 119 seconds. So it's effectively lost 2 minutes of footage in drop frames. But that's over in 3 hours. Yeah, don't know. I think I might stick to 720. Oh, let's close it off. Okay. Oh, another cat. This is Paul. You might see him on the thumbnails and all my videos. She likes attention, doesn't like being picked up so much. Gonna get down? Yeah, so I don't know. Not quite sure to go with that because see, the noise is definitely still there, and it's giving me confusing results, as I said. So it's puzzling. So what I think I might do is cut the stream off here. My throat's actually a bit sore. I've had a bit of a sore throat this week. I'm already feeling a bit sore, so I can't talk too much more. I don't think anyway. But yeah, I don't know. I feel a bit disappointed. I didn't actually achieve anything today, but it's interesting anyway, I suppose. But yeah, I need to sort of line something up for the next stream and actually figure out something I'm actually going to do. I didn't prepare very well. Yeah, I've got a few videos coming up. I've got 8 videos queued, plus ones I've already uploaded. So I've got 10 videos already basically recorded, and the ones for the following week, well, this week coming up, are already done. So the mailbag for tomorrow's done, and the repair video for Friday is done. There's a review video I kind of need to do. I'm not sure if I'm going to do it this week. I've recorded it, but I'm not sure if I actually need to publish it this week or can wait a bit longer, because if I do it in my queue system where everything's in a structured way so that things are in sequence, it won't be published for another 3 weeks. So I'm tempted to just do it early and have it go out of sequence and publish it this week. That's on the new soldering station I picked up, which I should probably tell you about actually. So I picked up a Jabe UD 1200 soldering station from Banggood, a review item for free. And I'm actually really impressed with it. It works really well. It's got some things I don't like about it. It's not perfect, but it's pretty good. Its heat up time is like 3 seconds from cold. From standby, it's literally a second, and it's going. It's incredible. Things I don't like about it, it's got a power switch on the back. Pet peeve. And the display angle is a bit shallow. When it could be done correctly, but the actual LCD is a bit hard to see because of the angle. Sort of, you know, that sort of slope. If you get it up to like this angle, it's fine. Like 45-degree angle, you can see it. But shallow angle is a bit hard to see. You can see it, but it's not particularly nice. So those are my 2 pet peeves. The rest of it is actually really good. So watch out for that video coming up. So I might do it this week. I'm not sure yet. I've got to edit it yet anyway. I haven't even edited it yet. So, but it's a good soldering station. It's actually displaced my KSGR. Is that KSGR? Yeah, KSGR. The one I've been using for, I don't know, over a year now. I've been using that, haven't I? Year and a half maybe? 2 years? Could be. Which is the one I got from Banggood originally as a review item. That's been my little desktop soldering station for that, and it's because that's worked fine with T2L tips. But this one's using a C, well, they call it a T, I'll get it right, a 2245 tip, which is like the JBC C245 tip, which is a high power tip, and it works well. So watch out for that anyway. Right, I'm going to cut this off and go and rest my voice and maybe have some lunch or something. Do it a little bit earlier, but yeah. Figure out something for next stream maybe. Do some editing, something like that. So I'll catch you later. Thanks for dropping by everyone, and give us a thumbs up before you leave. If you've not been subscribed before, you're not subscribed, then subscribe, and hopefully next one will be a bit more interesting. This one feels like a bit of a letdown to my usual streams anyway. I think it's still interesting, but okay, catch you later. Bye.